So, last class I started with plate load test or plate bearing test. So, in this test what you are supposed to get? Bearing capacity of your foundations or bearing capacity of soil, settlement, differential settlement, E modulus of elasticity, subgrade modulus as well as influence factors. So, how the plate load test has been carried out? Generally it has been carried out with a pit. It has been carried out with a pit with either circular or square plates of size 300 mm to 700 mm. So, generally what is the load you are supposed to apply? Load has to be applied, number 1/10 of estimated failure load, B 1/5 of proposed design load. So, that means bearing capacity failure means if you look at here, you apply the load intensity you apply either 1/10 of the estimated failure load or 1/5 of your proposed design load. Let me have this drawing, then you can have a very clear picture. Generally there is a pit, then it is a reaction frame here and it is supported by piles here. Then in this reaction frame this is a hole and this is pit, and there is a this part is your hydraulic jack and this is your reaction frame, and this generally we say it is dP, depth of the plate, and this generally we say width of this plate. So, this is your anchor pile, this is your anchor pile, and the pit size is about to be 5 times BP, 5 times BP by 5 times BP. So, generally the arrangement has been made dP by BP is equal to dF by BF. So, circular and square plates varying from 300 mm to 700 mm generally put it. So, first you prepare a pit, means where you want to find it out bearing capacity, settlement as well as E and K other parameters, you prepare a pit. Generally pit size should be 5 times BP. BP is your width of your plate, 5 times BP by 5 times BP. So, once you prepare a pit, then prepare your reaction frame. I will show you a video also, reaction frame with your anchor piles. So, this reaction frame will connected by means of your anchor piles. Then place a hydraulic jack here. This hydraulic jack put it here, and below this you put your plate. Then once you apply this hydraulic jack, what will happen? Hydraulic jack will apply load towards your reaction frame. Every action has equal and opposite reaction. So, because it is fixed, it will allow to push your plate. So, it depends upon how you are going to apply. So, pit size will be 5 times BP by 5 times BP. So, then what are the other things? Suppose you are consider only 1/10 of your estimated failure load or 1/5 of your proposed design load, then what happened? You apply, you find it out theoretically what is the bearing capacity. That part will come later. Theoretically what is the bearing capacity, then you decide what you are supposed to take it, either 1/10 or 1/5, then take the load increment, then apply this load by means of hydraulic jack, apply it, and this application will be constant. Then measure your displacement. How you are going to measure displacement? Here generally at the two edges, dial gauge, two dial gauges at the two edges you provide and measure the displacement. Why two edges? From both the sides you can observe, is there any differential settlement at the both the ends. So, settlement you have to record it. Settlement record means each load increment, what settlement you are going to record it, every 1 minute, 5 minute, 10 minute, 20 minute, 40 minute, 60 minutes, then 1 hour, 2 hour, like this. You record settlements, then where you stop it, not stop, where you apply your next increment load. When rate of settlement, when is your rate of settlement? Rate of settlement is less than 0.2 mm per hour. Rate of settlement is less than 0.2 mm per hour. That means if I take a dial gauge here, this dial gauge is placed, here is your plate, here is your plate. We are placing two dial gauges at two extreme ends. So, you have to record rate of settlement 0.02 mm per hour, 0.02 mm per hour. That means it should not be more than 0.2 mm. Then at that point you have to apply next load increment. So, this is the case. Then you observe it 1 minute, 5 minute, 10 minute, 20 minute, 40 minutes, 60 minutes, 1 hour, 2 hour, sometimes it continues days together, because you have to wait till your rate of settlement is less than 0.2 mm per hour. Then finally what you are supposed to get it? Each load increment, suppose you are putting a load increment 10%, then 20%, then 30, 40, 50, 60 of your theoretical load, then you are supposed to get load versus displacement, or you can say pressure versus settlement. You are supposed to get it. This is your pressure. What is the unit? Kilonewton per meter square. Then is your settlement. You are supposed to get, look at here, I may get this type of curve, I may get this type of curve, or maybe I can get this type of curve. This is a pressure versus settlement. Pressure means how much load you applied by means of your hydraulic jack, what is your load, load by area of your plate, from there you are getting your pressure. So, and settlement, settlement you are getting 1 minute, 5 minute, 10 minute, 20 minute, 40 minute, 60 minute, 1 hour, 2 hour, like this. For each load increment, suppose I am getting one load increment here, one here, one here, one here, one here. So, from there you are supposed to find it out ultimate load. So, in these two cases it will be very easy to find it out your ultimate load, because either it is a single tangent or by means of double tangent. Here in this case, how I am going to get it? I am taking the linear part of this initial part, linear part at the end, drawing the tangents where it intercept and mark it. From here I can get it Q ultimate, ultimate load of your plate, I can get it from there, and this curve also I can get it ultimate load of the plate. But these cases I am not supposed to get ultimate load. Now tell me how long I will continue, how long I will continue, what settlement I can continue, where I can stop it. As per your Bureau of Indian Standards, generally we continue till we are getting 25 mm of your settlement. You do it, do your plate load test, you achieve your 25 mm of your settlement in mm. In this case, somewhere else I will have to stop. Here it is your 25 mm. If you are getting this kind of curve, this kind of curve, that is fine. In that case you are going to find it out your Q ultimate load, and corresponding settlement is your, this is your corresponding settlement with respect to your failure load. But in this case you are not supposed to get it. In this case you go up to 25 mm of your settlement, up to here what you are supposed to get it, that is your ultimate load. Now initially it is for cohesionless soils, and it has been extended for cohesive soils, C5 soils also, as well as clay. For clay, QUF, ultimate capacity of your foundations, actual real foundation, is equal to QU of your P, ultimate capacity of your plate. From plate load test I am getting pressure versus settlement, from here I am getting ultimate load of your plate. Now from there I have to find it out what is the actual ultimate load of foundations. Now settlement of actual foundation is settlement of plate into BF by BP. Now for sand, ultimate load of your foundation or footing, ultimate load of your plate into BF by BP, and settlement of your footing or foundation, which is equal to settlement of your plate into BF BP plus 0.3 by BP BF plus 0.3 whole square. There are series of tests has been done. From there these empirical correlations come out. What you are getting ultimate capacity, that is for your plate up to that depth. particularly that depth you are getting plate ultimate bearing capacity. So, ultimate bearing capacity, once you know the plate for clay, it is same as your plate. For settlement of clay, particularly for footing, settlement of your plate, how do you get it? Suppose this is my ultimate load, right, this is the failure. With respect to that, what is your settlement? With respect to that failure load, what is your respective settlement? So, SP, settlement of your plate, into BF, width of your footing, by BP, width of your plate. For sand, ultimate capacity of your footing, ultimate load of your plate into BF by BP, settlement of your footing, settlement of plate into BF into BP plus 0.3 divided by BP into BF plus 0.3 whole square. Once you get a plate load test, from there you can get settlement of footing, bearing capacity of footing, both clay as well as sand. This is number one parameters. As earlier I have said, you are supposed to get it bearing capacity of foundation or footing, now we are getting settlement of foundation or footing, we are also getting. Now come back to influence factor. How we are going to get your influence factor? Influence factor, if I write it, immediate settlement, S is settlement immediate, then it is QU into B by ES 1 minus mu square into IF. This is your influence factor. So, from there if I make it rearrange it, 1 minus mu square by ES into I into Q into B. If I plot it, plot a graph, Q into B here and S, look at here, the slope is equal to 1 minus mu square by ES into I. For a particular soil, mu is particular that depth, mu is known, elastic modulus is known, then influence factor, then you are getting an influence factor at the center as well as at the edge. Suppose this is a plate or this may be a footing, so what will happen? If I say influence factor is here I is something, here I is something, what is my immediate settlement? Immediate settlement is your Qn into B by Es 1 minus mu square into I. What I am supposed to get it? I will get it both the edges, some part I will get it at center there is a settlement, at edge there is a settlement. So, I can get it influence factor IF, if I write it IF C, IF at center, IF corner at the corner. So, from there I am getting two immediate settlements, one at corner, one at the center. This is some mm, this is some mm. So, this minus this, and if this is B of footing, so it will be Bf by 2, width of foundation by 2. So, this will be, if it is x1, if it is x2, and this part will be x1 minus x2. So, then theta will be this by this, theta will be x1 minus x2 by b by 2, which is equal to 1 by b by 2 by x1 minus x2. So, you are getting in terms of radian. So, this gives immediate differential settlement. So, you can get it whether this differential settlement while doing your design latter part, from plate load test you can get differential settlement, whether this differential settlement is within this permissible limit or not. If it is not permissible limit, then redesign or change the soil conditions. So, this is a vital parameter you are supposed to get it IF. Now, another part, how I am supposed to get it E of the soils. Pressure, this is a pressure, or I can put it other way around. This is my pressure, this is a settlement. I can make it to load versus settlement. Suppose I am supposed to get it this kind of curve. I can get it either by means of E initial tangent modulus or second tangent modulus. So, initial tangent modulus, what I am supposed to get it from here, initial part is linear, I draw a tangent and with that slope I am going to get it ES, and second tangent modulus with respect to working load, I draw a tangent, from there I am supposed to get ES. Similarly, you can get subgrade modulus K. Subgrade modulus K, generally it has been used for your modeling. This part I will discuss later while doing this foundation design and analysis. This K part I will discuss it later. So, this is about your plate load test, how we are doing this plate load test, what are the parameters we are supposed to get it. Now, come to the limitations. What are the limitations? First one is your scale effect, then second one is your time effect, then third one is your plate load test does not give properties of soil, then fourth one is your reaction load, it is generally not more than 250 kilonewton. Fifth one is your water table. Limitations: scale effect, time effect does not give properties of soil, reaction load, water table. If you look at here scale effect, generally what happen? Plate size is, I put it in this way, this is my plate size, generally it is 300 mm to 700 mm. Now, look at the foundations or actual footing size. Footing size generally varying from 1 meter to 3 meter or more. What is scale effect? Now, the pressure intensity of this plate will be this is your pressure bulb. So, generally the influence will be 2B to 4B. I can put it 4 times of B. Here pressure intensity will be put it 4B, 4 into 3, here it will be at the depth of your 12 meter. Look at here, suppose it is 300 mm into 4, 1200 mm, 1.2 meter, here it is 12 meter. Now, even if I can say if this is my ground surface, we intend to conduct a plate load test, suppose at a meter of 2 meter depth. Suppose you are conducting a plate load test below 2 meter depth, below the ground surface, that means pressure intensity is about to be up to 1.2 meter, 300 mm plate if I am taking. Now, up to this pressure intensity you are getting your bearing capacity settlement, but actual footing whatever you are giving it here, if I am taking actual footing laying it here, then it will be much more deeper soil. So, this is a major scale effect. Despite that, it has been used widely everywhere else. Then time effect. The plate load test has been carried out for short term basis. You look at 5 minute, 10 minute, 20 minute, 40 minute, 60 minute, 1 hour, 2 hour, then you stop it 0.2 mm. But here it ignores about your long term consolidation settlement. Plate load test basically gives immediate settlement value, and another disadvantage is it does not give any properties of soil, C, phi, gamma, it does not provide anything else. Reaction load, maximum reaction load you can go to 50 kilonewton, but actual footing, if you look at here, actual footing here is maybe 100 ton load is coming there. So, basically reaction frame you are putting it, reaction load you are putting it, maximum capacity it can take it up to 250 kilonewton, beyond that you cannot take it. Last one most important, when there is a water table here, water table is here, what will happen? It will be very difficult to carry out your plate load test, and it is not going to reflect actual value. That means once there is a water table, what will happen? Gamma will be gamma submerged, so bearing capacity will be half. So, how you are going to do it? You take out the water by means of pumping, then do your plate load test. These are all your important limitations of your plate load test. Despite these limitations, the plate load test has been widely used everywhere else to get bearing capacity, settlement, differential settlement, modulus of elasticity, subgrade modulus. Subgrade modulus I have not discussed, I will discuss slightly later. So, I will stop it. Next class I will start standard penetration test as well as cone penetration test. I will go slightly faster because we will go to your foundation design afterwards. Thank you.